Okay, ladies and gentlemen, here we go. We're going to do some geometry. I'm super excited. Like, wow, this is going to be awesome. So, hopefully this won't take terribly much of your time because it's kind of a very straightforward concept. They just like to give us super tricky problems, as you know. So, we're going to turn to section 11.3 on page 757. Go. Okay. You're probably already on 757, so good job. Okay, so we're talking about volume of pyramids and cones today. There's formulas. You just use them and plug them in and go. Of course, this book likes you to have to work backwards to be able to find like the height or something to be able to then do the volume, but we can do it. No problem. You guys are awesome. So, I actually don't need this one, I don't think. So, this is the volume of a cone. The capital B, remember, represents the area of the base of the shape. And if it's a cone, it's a circle, right? So the area of the base times the height divided by 3. In your book, it has it set up with kind of different terms, but it's exactly the same thing. It's 1/3, because isn't multiplying something by 1/3 the same thing as dividing it by 3? Okay, so it's the same thing. Pi r squared. The reason they do that is because pi times radius squared is how we figure out the area of our base, which is a circle. They just wrote it all out for you, okay? So these two formulas are exactly the same thing. You can put them on those little cards that you guys can use on your test. Put it whichever one makes more sense to you. 1/3 times pi radius squared, and then we're going to multiply it by the height of the cone, okay? This is for pyramids. It's the same thing, except for in a pyramid, you have varying different shapes, and so they can't put the formula for the area of the base because it sometimes is a square, sometimes it's a rectangle. Sometimes in one of our examples, you see it's a trapezoid. So they couldn't put that formula, but it's the same one as cones. It's 1/3 the area of the base and the height, and you multiply them, okay? Or I divide by 3, because to me that's a little easier than having to plug in a 1/3 into my calculator. So let's look at example number 1A. A rectangular pyramid, and what that's trying to tell you is that the base of your pyramid is a rectangle, okay? And the rectangle is 7 by 9, 7 by 9. And it's a pyramid, okay? So it looks like this. Okay, it's a rectangular pyramid, and its height, which it goes straight down the middle to the center right there, that height, it says, is 12. Okay, so there's our little picture. So we're going to do our formula for volume of a pyramid right here. The area of the base, what shape is the base? It's that rectangle, right? So to get the area of a rectangle, we do base times height. So 9 times 7 for the area of the base. They wrote it out. I'll just do the same thing. Times the height, and the height in our picture is 12. Okay, and then you can times it by 1/3 or divide by 3. And when you're done, you should get 252, it says. And what measurement? We're dealing with feet, and we're going to use cubed because it's volume. Okay, pretty straightforward, I think. Let's look at B, a square pyramid. So if it's a square, all the sides of the base are the same, right? So it's a square, it's a pyramid, so it's going to look something like this. Okay, and the sides are 4 by 4, and the height is 6. So we're just going to go, I'm not going to take time to do this. It's just like the other one that we just did. Okay, let's turn to example C. Example C is a trapezoidal, super fun word, trapezoidal pyramid. There's the base, A, B, C, D. And A, B, and C, D are the parallel bases. And AE is perpendicular. So it's showing you about the trapezoid there. So to find the area of a pyramid, we still use this formula, but in this case, our base shape is a trapezoid. So I put that formula here to remind us. In our trapezoid, we have 9 here. Well, you can't read that. 18 here, and it looks like our height, I'm being very careful not to mix the ink colors. Don't worry. Okay, and our height is 6. Okay, so base 1 plus base 2 times the height divided by 2 is the area of our trapezoid. Okay, so I think they do that for us, and they get 81. Okay, that is the area of the base of our pyramid. We're now going to multiply it by the height of the pyramid, which I think is 10. So we multiply that by height, which is 10, and we would then divide by 3 or multiply by 1/3. Okay, and when you're done, you should get 270. Okay, so that's that one. Example number 2 is just a word problem where you have to find the volume. I think on this one, what's different is that you have to convert acres in yards, maybe. Yep. The base edge is that many yards. Okay, so you just have to do a conversion before, just like sometimes you have to change inches into feet or something like that. But other than that, it's a straightforward volume problem. Okay, moving on to 759 is cones. Cones are the same. Remember, I told you the same formula, only the base is a circle, so they sometimes write it out exactly the way it needs to be. Okay, so let's look at our cone there. On example number 3, a cone has a radius of 5 centimeters. So that guy right there is 5. And it has a height of 12. Height, it has to be the actual height, a perpendicular height. Can't be like the slanty height over here, okay? All right, so we just do pi times radius squared times the height divided by 3 or multiplied by 1/3. Hopefully it's pretty straightforward, I hope, for you guys. And it would be 314.2. It says to give my answers in terms of pi and rounded. I don't care, do one or the other. You don't have to do both, okay? If you do answer it in decimal, please follow the directions and actually round to where they want you to round. And don't give me a fraction if they ask for a decimal, okay? So you can do it one way or the other. You can leave it in terms of pi or give me a decimal, but make sure you round to the nearest tenth or whatever it tells you, okay? I'm not going to go through the rest of those cones. Sometimes, like on 3C, you're going to have to use the Pythagorean theorem to get something that you're missing to then be able to solve the problem. So watch out for that. They'll do that to you. You know how they do that. They give us the circumference, so we have to work backwards to find the radius, so then we can use the volume formula, something like that. Okay, so just watch out for that. Example number 4, we've done these already as well. We did these in yesterday's section. If the dimensions of the figure change by 1/4, what is the change in the volume? Remember we did those? It's just whatever the change is, the change in the volume will be that change cubed, okay? Remember with area it's squared, but with volume we cube the change, all right? And then with 5, it's just composite shapes, so you're gonna wanna break it into different pieces. So I would do the volume of a cylinder. Did we do the volume of a cylinder yesterday? Base times height, I don't remember. I'll write it up here just in case. I actually erased it earlier. Ha, good work. There's a volume of a cylinder just in case you need it. Okay, so I'd take the volume of the cylinder, I'd find the volume of the cone, and then I'd add those two together. Smash them together, add them together. That's your composite shape. Okay, on check it out, 5 in the middle of the page there, that's like a rectangular prism subtracting out a pyramid. So be careful with your pictures and make sure you're kind of looking at them. Okay, if you look over on 11, 12, let's look at 12 on 761. That's a cone minus that inside cone. So that's what they want you to do for that one. Okay, so just kind of, those are a little bit tricky. I wonder if I have to look at another one. Oh, on number 22, it's the cylinder minus the cone. Okay. All right, so I think that wraps that up. Let's look and see what wonderful humor I have for you today. Okay, ready? Question, what has a circular base and is surrounded by water? Oh, you're gonna love this one, I can tell already. A circular base and is surrounded by water. Coney Island. Told you, love it, love it. Okay, have a great day. Bye.